So a little bit of review with our factoring synthetic division and analyzing polynomials. We're going to start with the synthetic division with a reminder, besides the fact that I can't spell remember, it looks like. We've got to remember to switch signs when we're doing this. So I'm actually going to jump to the one that looks the trickiest, which is number 4, just because it's the longest one. So when we're going to use synthetic division, you go to your binomial term, and whatever value you see here, in this case it's plus 1, we're going to put the opposite in our little box. So if it's plus, we use minus. If it's minus, we use plus. We get that in there. From there, all I want to do is use the coefficients. First, I check to make sure there's no holes. 3, 2, 1, 0. Okay, I don't have any this time. And so I'm just going to write the coefficients of those 4 terms down. And then I just got to remember how the process works, and this will go fairly easy. So I'm going to drop that first term down. I don't do anything with it. And now it's just become a multiply and add game. 5 times negative 1 is negative 5. Add down, whatever my answer happens to be. And the biggest thing here is I just got to be really careful with my signs. Negative 2 times negative 1 is positive 2. And add down. Negative 9 times negative 1 is positive 9. Add down. Once I get that part done, the only thing I have left is to put the variable terms back in. And the only thing I really got to remember on that is whatever degree I started with. So I started with x to the third in this problem. I start one below that. So I'm going to start with x squared, then x, then my constant term, which would be my 0, I guess. And if I have a value left here on the end, that's my remainder, which I just put over my divisor. And I'm set. So the 2 biggies, remember to switch your sign. And then if you have that value at the end, that we put it over whatever we were dividing by at the start. That's our synthetic division. Now this next part's the one where I think we'll have some kind of issues here. So I'm actually going to jump to the back because it's the screwiest one. So I'm going to go to number 8. So we're going to see something that looks a little bit strange here. So okay, we are going to be looking for zeros, minimums and maximums, increasing, decreasing. Okay. So it's probably a good idea to get a graph on here first. It'll make life a little bit easier. So we'll go ahead. Biggest thing here, of course, is to make sure I'm actually typing the right equation and that I don't mess this up somehow. So x to the third minus 4x squared plus 2. So first I'm just going to look at the graph just to get an idea what this is supposed to look like. All right, that's kind of funky. So now to make it a little more accurate, just a little bit, I'm going to go ahead, I'm going to pull up my chart, and I'm going to start looking for some values that I could actually plot. So like I notice, negative 1, negative 3, okay. 0, 2, 1, negative 1, 2, negative 6, 3, negative 7. Well, I get a lot this time. 4, 2. Now, those points themselves aren't going to help me very much because that looks like a big old hodgepodge mess. But once I get those values on there, then I can go back and I can look at the graph again. And now as I look, I'm like, okay, this starts to make a little bit of sense now. It's like this way, okay. All right. And again, I'm not looking for complete accuracy, but that does look pretty good compared to the one that I have already. So now that I have this, what does that mean? How do I find what I need? So the first thing I'm supposed to be looking for zeros or x-intercepts. So x-intercepts occur where my graph crosses the x-axis. So I notice that there's 3 of them. I got to find all 3 of those. So for my zeros, for every one of these things that I'm looking for, I'm going to use the second and the trace on my calculator to get to the calculate menu. But then once I get there, it depends on what I'm looking for and which number I'm going to use. So for instance, on my zeros, I'm going to use number 2. And this goes back to when we had that little cheat sheet before on saying, okay, how do I find these again? So I'm going to get my little cursor guy as close to the intercept as I can. So I'm just going to start with the one furthest to the left here. And then I go 1, 2, 3 arrow clicks to the left. I hit enter. My left border gets put in. 1, 2, 3 to the right to get back where I started. 4, 5, 6. With another enter, and now I notice my 2 borders are trapping that 0 in. If I hit enter one more time, I see that one of my zeros, and I think it's set to the nearest 10th, so that would be negative 0.7. That would be this one. You're like, so do I have to start all over to find the other ones? I do. I got to do second trace and 0. I have to reset it each time. So then I notice the next one's right here. So again, I get as close as I can. Once I get there, 1, 2, 3 to the left, enter. 1, 2, 3 to get back where I started. 4, 5, 6. I notice again with my borders, my 0 is trapped in the middle. That's what I'm supposed to be doing. And I hit my enter, and this time I'm at 0.8 if I'm going to the nearest 10th. 2 down, 1 to go. Second trace, one last time. Another reason I like this one, we get plenty of practice. So I finally get around to that last one. Again, as close as you can get, you may not be right on the axis. So once I get to that last one, 2, 3 to the left, enter. 1, 2, 3, gets me back where I started. 4, 5, 6, enter, enter. 3.9, let's say. Okay, so those 3 are my zeros. Okay, so I'm also asked to find the minimum and maximum values. So for this particular one, I see a maximum up here at the top, because again, when you have a hill or something that looks like a hill, that's where you're going to find your maximum. When you have something that looks like a valley or a U, that's where your minimums are going to be. So it looks like I've got one of each of those on this one. Okay, so how do I find those? Second trace. Let's say I'm going to look for the maximum first. So the max is number 4. I hit that, and it basically works the same way as my zeros do. I arrow over until I get to the very top of what looks like to be my maximum. And then I do 1, 2, 3 to the left, enter. 1, 2, 3 to the right, 4, 5, 6. And again, I've got my borders here, which are trapping that in, and I hit enter. And remember, if you see E show up, let me zoom this a little bit more. So some of you can't see the E, you'll be able to here. E just means 0. So my maximum here would be at 0, 2. And I got to write the X and Y value for maximums and minimums so I know where they're at. So that's my max. We got that guy. Next stop, my min. Second trace. Minimum is number 3. Same thing. Arrow until you get way to the bottom there. It's pretty close. 1, 2, 3 to the left, enter. 1, 2, 3, 4, 5, 6. Enter again. We've trapped that in, which is what we want to do. And my minimum looks like it's at 2.7, negative 7.5. You're like, okay. Hey, we're doing a lot of stuff here. Last thing to deal with. Okay, increasing and decreasing, which is the new stuff. So let me chat about that here for a second. So when we're dealing with increasing, decreasing, increasing just means when I start at the left of my graph and I start to go to the right, which direction am I going? Well, I'm going up. I'm increasing. So I notice here at the start, I'm increasing from negative infinity, where I start my graph. Well, where do I stop increasing at? When we're looking at increasing and decreasing, we're always looking at the x values. So what's my x value right here? Well, that's where my maximum is at. My x value is at 0. So, from negative infinity to 0, I'm increasing. I'm going up in value. Now, what I like to do is I kind of keep just working on the graph that I have instead of changing this up too much. So, I'm going to put my decreasing right below here. Once I start up here at 0, it starts to go down. So, start at 0 and I start going down. Well, I stop going down when I get to the minimum. Well, I don't know. What value is that? Use the x value of your minimum. 2.7. So from here to here, it's going downward. Well, then what happens? Well, now it starts to go up again. So where does it start going up? The same place it stopped going down before. 2.7. And it just keeps going up and up and up forever. So when we're doing increasing, decreasing, using a colored pencil, using different colors of pens and working left to right is helpful. But here's the even bigger thing that's helpful. If you know the maximum and minimum values, those will tell you what numbers to use when you're increasing and decreasing, because that's where your stops are going to be. That's why I was using different colors in here to kind of make that jump out a little bit more at you and make it a little easier to see. So that's how those work along with the buttons that you'd hit to find them. Okay. And then the last thing on here is dealing with some of our factoring, our special factoring from before. So we're going to take a peek at numbers. Let's see what we got here. Number 11. Ooh, that doesn't look like fun. Number 11, number 12. I suppose I should probably move the paper up if I'm talking about them. Okay, number 11, number 12, and number 16. So, when we're factoring, we are going to pair our terms off, and we're going to deal with them like two separate problems. So for instance, here on number 11, I look at those first two and I say, okay, is there a number that divides into 10 and 15? Yes, there is. Okay, the biggest number that divides into both is 5. Then I look at my exponents and my variable values. Do they have something in common? Yes. You take the one with the smaller of the two exponents. So 5n squared. And then you just make a set of parentheses with what you'd have to multiply this by to get this back. 5 times what gets me to 10? 2. I got 2 n's, I need 3. I need 1 more. 5 times what's negative 15? Negative 3. And I already have 2 n's. So I have a hint for my second one. Whatever I pull out, this has got to be what's left over, or I did something wrong. So, switch them up here. 16 and 24. You're like, okay, 8. But then you go to look inside, and you're like, well, wait a minute. 8 times negative 2. That's not right. Okay, let's try negative out here. Negative 8 times positive 2 would be 16n. Okay. Negative 8 times negative 3 would be positive 24. All right, that's good. And so to get the final answer, I've done all the hard work. The common set of parentheses, that's one part. And then my greatest common factors that I had from when I did the individual pieces is going to be my other part. And I'm set. Okay, there's no other real way to do this, though. I got to kind of divide and conquer on these. But I always have to have those two sets of parentheses that are the same when I'm grouping. More factoring. Oh, more factoring. I see a couple of things that make me think. It's only two terms and I see a 3, so I'm like, ooh, cubes. Now, I do have some other news as well that I can share on here. Remember our flowchart here for when we were doing our factoring and stuff? These will be usable on the final, but I'll give you a new one on finals day. So here's how that's going to help me right now, though. If I get this down right. Okay. I'm going to have a list of perfect cubes, so I'm not going to have them memorized. That's a nice thing. But you're like, Harty, you're talking about cubes. 256 and 500 aren't on this list. That's true. But do we have a common term I could take out? Well, let's find out. Let's see here. Let's try dividing some numbers in and see if we can find something that goes into 256 and 500. Okay, now 2 does. But I'm kind of looking at those two numbers, and it looks like something to go in again. So let's try 4. 64 and 125. Ooh, wait a minute. 64 and 125. 64 and 125. Okay, I'm happy now. So if I take out a 4, I have 64m to the third, because 256 divided by 4 is 64, plus 125, because 500 divided by 4 is 125. Cool. So now I've got to start working with my sum of cubes, which again, happy, that's on the flow chart. So all I'm going to have to do through this is figure out, what do I cube to get 64? 4. And I cube m to get m to the third. And I cube 5 to get 125. That's my A and my B term. So now I can just follow what's on here. I don't even have to worry about doing it myself. So, first job, take my two terms, keep their sign in the middle. 4m plus 5. Now what? Take my first term and square it. Square the 4 and the m, so 16m squared. Change the sign. So I started with plus, I go to minus. Multiply a and b together. So 4m times 5 is 20m. And then my b term, my second term, squared. 5 times 5 is 25. Okay, will I always have to take a common term out to get the perfect cubes? No. But if you're not seeing these values when you see something to the third, it probably is because you need to take a common term out. Okay, so that would kind of give me a heads up on 12, 13, 14. When I get to the last three then, I still want to use my golden rule. You know, is there a number that divides into 20 and 45? I don't know. Let's see. Well, 2 didn't work. Ooh, maybe 3. Whoa, Harty, going crazy. Definitely not 3. So notice sometimes I may have to play around a little bit. Like, Harty, this is driving me crazy. That's why I need to know my division facts off the top of my head. Okay, I found one, 5. So if I take out the 5, my 20, that leaves me with 4k squared. With my 5, it leaves me with 9. Wait a minute, that looks familiar. Perfect squares, 4 and 9. Difference of squares, right here. But remember, the thing you have to remember on these is, what do I square to get each of these terms? I square 2k to get 4k squared. I square 3 to get 9. And now, I have everything I need. There's my A and my B. 2k goes first. 3 goes second. With a plus and a minus. that, ladies and gentlemen, gives us a pretty good cover on kind of taking a peek at some of these and seeing how they work. Now again, with no homework check on this, I'm not going to force the issue, but I've got a key. You can check, kind of see how it's going, because the stuff does show up on the final, and we really don't want to miss stuff on the final. So that will wrap up our mini review of this week's activities.